Hello everyone. Hope you have enjoyed the previous video. Today let's continue with the topic traveling now and then. Before I start, I request you to subscribe my channel so that you get latest videos as and when it is uploaded. So let us start. We learned that people in the past traveled on foot, on animals and used boats and sailing ships. The animals that have been used for traveling include bullock carts, horses, donkeys, mules, and elephants. In hilly and snow covered regions, yaks, dogs, and reindeers have been used, while camels have been used in deserts. Now, people use bicycles, motorbikes, cars, bus, trains, ships, and aeroplanes to travel from one place to another. Submarines are used to go deep underwater. Humans are also using spacecraft to travel to our outer space. Here we have seen different modes of transport people use to travel to different places and different regions. In an hour, a person can generally travel 3 to 5 kilometers on foot, 10 to 15 kilometers on horseback, 12 to 20 kilometers by cycle, 40 to 60 kilometers by motorbike, 40 to 160 kilometers by train, 25 to 45 kilometers by ship, 750 to 920 kilometers by aircraft, and minimum 28,000 kilometers by spacecraft. Different means of transport and the distance can covered by a person is listed here. Now let us do some questions. First question, a cyclist can cover 15 kilometers in 1 hour. How much distance will she cover in 4 hours if she maintains the same speed? Distance covered in 1 hour is equal to 15 kilometers. Is given in the question. Distance covered in 1 hour is equal to 15 kilometers. Then how much distance can be covered in 4 hours? Distance in 4 hours is equal to 15 kilometer into 4. 1 hour 15 kilometer. So 4 hours 15 into 4. 15 fours are 60. So 60 kilometer can be covered in 4 hours. A school has 461 girls and 439 boys. How many vehicles are needed for all of them to go on a trip using the following modes of travel? The numbers in the bracket indicates the number of people that can travel in one vehicle. So, to do this one, first we have to calculate the total number of children in the school. Total number of girls is given 461 and number of boys 439. So, total number of students, how many are there? Total number of students is equal to 461 plus 439. Together we will get on addition 900. 900 children are there in the school. Now we have to calculate the vehicles needed for each mode of travel. Modes of transports are given. First one A, bicycle. 2 people per bicycle means 2 people can travel. Number of bicycles required. Number of bicycles needed is equal to total students divided by capacity of one bicycle. Total students, how many are there? 900 divided by how many can travel in a cycle? 2. 900 by 2. On division, we will get it as 450. Bicycles are required. Now we are moving to B, auto rickshaw. In an auto rickshaw, how many children can travel? 3. Auto rickshaw, 3 children can be travel. Total number of children we have 900. So now number of auto rickshaw required is equal to 900 divided by 3. One auto, 3 children can travel is equal to, on division we will get it as 300. Now come to see car. In a car, 4 children can travel. Again same way. Number of cars required is equal to 900 divided by 4 is equal to 4 twos are 8. On division we will get 4, subtracting 1 10. Again 4 twos are 8, subtracting 2 20, 4 5s are 20. So answer is 225. 225 cars are required. Come to D. Big car. The capacity is 6. 6 children can travel. So number of big cars are required is equal to 900 divided by 6 is equal to 150. Like the previous case, you can do the division. Come to the next one, E. Tempo traveler. In a tempo traveler, 10 children can travel. So how many tempo travelers are required? Number of tempo travelers required is equal to 900 divided by 10 is equal to 90. Next one is boat. In a boat, at a time 20 children can travel. Then how many boats are required? Number of boats required is equal to 900 divided by 20 is equal to 45. Next portion, G. Minibus. Like the previous cases, here also we have to do the division 900 by 25. On division we will get it as 36. And next one, aeroplane. One aeroplane can carry 180 children. Then how many aeroplanes are required? 900 divided by 180. We will get it as 5. 5 aeroplanes are required to carry 900 children. Finding large numbers around us. We saw that the distance in kilometer covered by different means of transport in an hour can range from a one digit number to a five digit number. One digit number means the person can travel on foot, and five digit number, that is by spacecraft. Can we find other contexts around us that contain number in this range? Let us consider the situation below. A book has around 200 pages and each page has about 50 words. The book therefore has about 10,000 words in all. Find something in the textbook whose count is a four-digit number. For example, we can use the letter A. The letter A, minimum it comes 1000 times. For the smallest four-digit number is 1000. So we can say the letter A. Now let us try this with our school. Our school has near about 50 classrooms. There are 40 students in my class. Our classroom has dash books in total, 200 books in total. Each child is having 5 textbooks, total 200 books. Find something in the classroom whose count is a 4-digit number. For example, our maths textbook is having near about 200 pages. There are 40 children in our class. So together, how many pages are there in the maths textbook? We have 8,000 pages altogether for 40 children. So it's a 4-digit number. Come to the second one, 5-digit number. For this, you take maths textbooks and EVS textbook together. Both have near about 200 pages. So maths and EVS textbook together, there will be 8,000 plus 8,000. We have 16,000 pages. It's a 5-digit number. List some quantities whose count is a 4-digit or a 5-digit number in the context of a tree. It's very easy. A tree, number of leaves on a tree. That will be, anyhow, it will be more than 4-digit number. That is more than 1,000. Your village, town or city or any other place of your choice. The population, number of people living in that village or in the town or in the city. It will be a 4-digit number. Pastime mathematics. Sanju and Mira are traveling on a train. To pass time, they challenge each other with games and puzzles. Mira poses the river crossing puzzle to Sanju. A boatman wants to cross a river in a boat. He has to take a lion, a sheep, and a bundle of grass with him. He can take one of them at a time. If the sheep and grass are left on the shore, the sheep will eat the grass. And if the sheep and the lion are left on the shore, the lion will eat the sheep. How can the boatman take the lion, sheep, and grass across the river? Help him so that he can ferry the lion, sheep, and grass across the river safely and in the minimum number of trips. Here, there are some rules. First one, the lion will eat the sheep if left together unsupervised. The sheep will eat the grass if left together unsupervised. The boatman can carry only one item at a time. These are the 3 rules. Lion and sheep cannot live together. Sheep and grass cannot live together. One thing can carry at a time. So here the solution will be, first one, take the sheep across and leave it on the other side. Take the sheep. And leave it on the other side. Then second step, go back alone. The man is coming back to the other shore. Third step, take the lion across. Then fourth step, bring the sheep back. He cannot leave the lion and sheep there together. So bring the sheep back. Fifth step, take the grass across. Sixth one, come back alone. Seventh step, take the sheep across again. All the 3, lion, sheep and grass, are safely on the other side. Sanju introduced a game called Pile of Pebbles to Mira. There are 2 piles of pebbles. Each pile contains 7 pebbles. Each player can pick as many pebbles they want from either of the piles. The player who picks the last pebble wins. Try this game with your friends. Now, how do you play it so that you win? To find a winning strategy, try playing with one pebble in each pile, 2 in each, 3 in each, and so on. Now it's Mira's turn. She gives a fun puzzle to Sanju with the following steps. Take any two different digits, for example 3 and 7. Make two-digit numbers using them, 37 and 73. Subtract the smaller number from the bigger number, that is 73 minus 37, we get 36. Now use the two digits in the difference and repeat step B and C. That means repeat the process with the new difference 36. Continue this process until you get a one-digit number. Even before everyone could finish, Mira exclaimed, "Mind you, no matter which two numbers you choose, you will get 9 in the end." The whole process will look as shown below. First, the number 73 minus 37, we got 36. Then interchanging the digits 63 and 36, we subtracting, we will get 27. Again 2 and 7 interchanging, making the number 72. Subtracting 27 from 72, getting 45. Now again interchanging the digits, making the number 54 and subtracting 45 from 54, gets 9. How did Mira know what the one digit number in the end would be? No matter which two digits you start with, you will always reach 9. This happens because of the specific way the digits and their differences interact during subtraction. The difference always reduces to 9 regardless of the initial digits chosen. Whatever may be the initial digit, the final answer will be always 9. Let us explore. Observe the differences you get in each step above. Do you notice anything common? What is common? Have a look at these differences: 36, 27, 45 and 9. All these are multiples of 9. All are multiples of 9. Try the puzzle using any other pair of digits. What is common to these differences? What do you get in the end? For example, let us take 59, 5 and 9. Digits 5 and 9 form the two-digit number 59 and 95. Find out the difference. 95 minus 59, we will get 36. Again interchanging, 63 minus 36, we will get 27. Again interchanging the digits 2 and 7, we will get 72 and 27. Finding out the difference, we will get 45. Interchange the digits 4 and 5. The new number formed will be 54 minus 45, we will get 9. Here also the final digit is 9, ending with a 9. What digits can you choose so that you get a one digit number in the first step itself? We have to choose 4 and 5. 4 and 5, 45 will form and 54 will form. Together two digit numbers. 54 minus 45. What will be the final answer? 9. In single step, we landed the digit 9. Here, we can choose any two consecutive numbers. The answer will be, the difference will be always 9. Any two consecutive numbers. For example, we can take 3 and 4. 3 and 4 numbers formed will be 43 and 34. Subtract 9 will be the difference. And 23, 32. 32 minus 23. 2 and 3 are consecutive numbers. Difference is 9. Or we can take 54 and 45. Already we took. So if you choose any two consecutive digits and form the number, the difference will be always 9. Now find different digits such that the difference between the number is 27. We can select the digits 3 and 6. Number formed is 63 and other one is 36. Subtracting, we will get 27 as the difference. Next question. Mira found an interesting relationship between the two digits and the difference obtained. Can you see it in the table that Mira made? She used the digits 3 and 7. Difference between 7 and 3 is 4 and difference in numbers formed by the digits 73 minus 37 is 36. That is 4 nines are 36. Now 1 and 9 are the digits. Difference between the digits 9 and 1 is 8. So what will be the difference in the number formed? 8 nines are 72. Now the digits are 2 and 8. Difference between the digits 8 and 2 is 6. So what will be the difference in the numbers formed by these digits? 6 nines are 54. 4 and 5 are the digits in the next case she used. Difference between the digits 5 and 4 is 1. So the difference in the number formed is 1 nines are 9. Extending this table by choosing appropriate digits so that the resulting differences are 2, 3, 5 and 7 respectively. We can take the numbers 5 and 3 to get the difference 2. 5 minus 3 is 2. To get the difference 3, we can choose the digits 4 and 7, then form the number and subtract. 4 and 7, 47 and 74 and carry on. To get the difference 5, we have to take the digits 3 and 8. 3 and 8. Difference is 5. To get the difference 7, we can take 2 and 9. And we have to form the digits 29, 92 and subtract. And finally, the difference between the number formed will be 9. What do the differences between the digits indicate? The differences between the digits, example 4, 8, 6, 1, 2, 3, 5, 7, etc. directly indicate how many units of 9 the differences between the form number will be. For example, consider the first line 3 and 7 digit we have taken. The differences between the digits 7 and 3, 4 and the differences in the number 36. So, what is the connection between 4 and 36? 4 times 9 is 36. If we select 1 and 9, difference between the digit is 8 and differences between the number formed is 72. So, 8 times 9 is 72. The differences between the digits, how much is coming? 8. So 8 times will be the differences in the number formed. Now come to the next question. List the numbers that give a one digit number in the third subtraction. To get a one digit number in the third subtraction means differences between the digits should be 3. So we can take 4 and 7, that pair, 4 and 7, or 3 and 6. Their differences should be always 3. 2 and 5, these pairs we can take. Identify the pairs of digits that lead to the one digit number after the maximum possible number of subtractions. Compare your answer with your friends. So, to get this one, we have to choose the smallest one digit number and the biggest one digit number. Smallest one digit number is 1 and the biggest one is 9. So the number formed will be 91 and 19. 8 times we have to subtract to get the one digit number. Let us conclude here. In the next video, we will continue with the next topic. Thank you. Stay tuned to get more updates. Don't forget to like, share and subscribe my channel.